Alright guys, here's your lesson on ellipses. So we have official definition of an ellipse over here. It's a set of all points in a plane such that the sum of the distances from two fixed points, the foci, is constant. So what that looks like graphically, if I were to actually sketch a graph over here, so your ellipse looks like an oval. So it can either look like a football if it's longer horizontally or look like an egg if it's longer vertically. So here is an ellipse. Your foci is 2 points inside the ellipse. So we'll say the foci is about right here. So with the definition is saying that it's a set of all points in a plane such that the sum of the distances from two fixed points is constant. So if I have, let's say I have this point, and I have this distance plus this distance is going to be the same as if I had this point down here. So that distance plus that distance. So if I were to add these two distances together, this line and this line, it's going to give me some sum, or some distance. And then if I were to do these two distances and add them together, it should give me the same distance. So that distance, the sum of these distances from these two fixed points, is constant. So we have two standard forms for the ellipse. The only difference between them is the positioning of your a squares and your x's and y's. But instead of sitting there and memorizing all of these formulas, I'm just going to go through the first example with the graphing. Alright, so your center for the ellipse is at HK. So HK is what's inside the parentheses, with H being associated with the X, K being associated with the Y. So in this case, your center is at 0, 0, since we don't have numbers in the parentheses. To figure out if you have a horizontal or a vertical major axis, you're looking at what's underneath the fractions. So underneath my X, is a 36, underneath my y is a 9. So if you look back at your original standard form equations, we have a squares and b squares. A squared is always the bigger number. So in this case, a squared is 36, b squared is 9. If the bigger number is underneath the x, that means your ellipse is bigger horizontally. If the bigger number is underneath the y, that means your ellipse is going to be bigger vertically. So in this case, we have a bigger number underneath the x, so that means we are going to have a horizontal major axis, which means it's going to be longer horizontally. I'm going to go ahead and plot my center. A squared is the bigger number, so since a squared is 36, a is going to equal 6. A is the distance between a center and the endpoint of your major axis. So we know the major axis is horizontal. Okay, so if I move horizontally 6 units in both directions, that's going to create my major axis. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that means completely across, my major axis is 12 units. Your minor axis is going to be associated with b. So b squared is 9, so that means b is going to be 3. B is the distance from your center and one of the endpoints of your minor axis. So if my major axis was horizontal, my minor axis is going to be vertical, which means I'm going to move up 3 and down 3. And that's going to give us our elliptical shape. So the length of my minor axis is 6 units completely across, so it's going to be 6 units. And then now that I have those 4 points, I can go ahead and sketch my ellipse. So your ellipse should look something like that. We do still need to figure out where the foci are, because without your foci you wouldn't have an ellipse. To figure out your foci, you're going to use the formula c squared equals a squared minus b squared. A squared is your bigger number, so a squared is 36, minus b squared, which is 9. So that gives me c squared equals 27. So c is going to equal the plus or minus the square root of 27. And the square root of 27 is approximately 5.1. So I have plus or minus, actually 5.2. Plus or minus 5.2. So C represents the distance from your center to one of your foci. So if I'm starting at my center, and your foci is always on your major axis, I'm going to go 5.2 units to the right. There's one focus. I'm going to go 5.2 units to the left, and there's my other focus. Now, since your center is at the origin, it's pretty easy to count. Sometimes your center is not always going to be at the origin, so to actually figure out your ordered pairs without looking at the graph, you need to manipulate your center. So my center was originally at 0, 0. So I'm taking 5.2 and adding and subtracting that horizontally, which means my x-coordinates are changing. So I'm going to take my x-coordinate of my center, and I'm going to add and subtract 5.2. My y-coordinate is going to change the same because we're not moving up and down at all, just to the left and to the right. So one focus is at 5.2 and 0. The other one is at negative 5.2 and 0. And then that creates your ellipse. For letter B, your bigger number is underneath the y, which means you are going to have a vertical major axis. Your center, please be careful, so your center for this is going to be at positive 4, negative 1. So I'm going to go ahead and plot my center at positive 4, negative 1. Make sure you keep track of your x's and y's, by the way. To figure out how many units I'm going to move vertically, since my major axis was vertical, I need to find a. So a squared is my bigger number, so a squared is 64, so that means a is going to be 8. So I'm going to move up and down 8 units. And then down 8. And then that creates my vertical major axis. So this entire length of cross is 16 units. For my minor axis, I need to find b. b in this case is going to be 5, since b squared is 25. So I'm going to move to the left and to the right 5 units. And then that helps me create an ellipse. So there is our ellipse. And my minor axis was 10 units in length. To figure out where the foci are, we need to find c. So I have c squared equals a squared minus b squared. So I have c squared equals a squared, in this case is 64, minus b squared, which is 25. So that gives me c squared equals 39. So c equals plus or minus the square root of 39, which equals 6.2. Now, your major axis was vertical, which means your foci is moving vertically from your center. So I'm moving up 6.2 units and down 6.2 units. To find out exactly where these points are, I'm going to go ahead and take my center and manipulate my y-coordinates, because my x-coordinates aren't going to be changing at all. So I have 4 and then negative 1 plus or minus 6.2. So my x-coordinates are the same. For my y-coordinate, I have negative 1 plus 6.2, and then negative 1 minus 6.2, and then that's where your two foci are going to be. So 4, 5.2, and then 4, negative 7.2. And that creates your ellipse. Alright, so now we have the graphing out of the way. Let's go ahead and start writing equations. To be able to write the equation for an ellipse, you need to know what A, B, and the center are. So we're looking for A, we're looking for B, and we need to know what the center is going to be. Not C, because C is for your foci. We need to know what the center is. Okay, so if you're given a graph, finding your center is very simple. You're just finding the center of your ellipse. So just by looking at the graph, I can see my center is at 0, 2. Now, you don't necessarily want to trust the graph every single time, but what you can do if you don't trust the graph is you can find the midpoint of your endpoints. So from negative 4, 2 to positive 4, 2, the midpoint of that's going to be at 0, 2. So my center is at 0, 2. Now that I know my center, I can go ahead and set up the top part of our equation right away. So this is my h, and that's my k. So I have x minus h. Well, x minus 0 is just x. So that gives me x squared plus y minus k, quantity squared, equals 1. Now in this case, your major axis is horizontal. Okay, so horizontally I'm 8 units across, so that means A is going to be 4. My minor axis is the shorter length, so that's 6 units across, so B is going to be 3. Now since your major axis was horizontal, that means the bigger number is underneath the x. So it's always a squared underneath, so that's going to be 16 underneath my x, and then 9 underneath the y. So this is the equation that represents this ellipse graphically. For letter B, we still want to find our center. Our center in this case is at 0, 0. So the top part of our equation is going to be x squared plus y squared equals 1. And we just need to figure out what goes on underneath. So A is the distance between your center and one of the endpoints of your major axis. We know that this is your major axis since your foci are sitting right on top of it. So in this case, A is going to be 5 units because here's an endpoint, here's another endpoint, so A is 5. Since we're given the foci, we can figure out what C is. So C is the distance between your center and one of your foci. C in this case is 3. And now that I know that A is 5 and C is 3, I can use this formula, a squared minus b squared, to figure out what b is going to be. So that gives me 9 equals 25 minus b squared. Subtract 25 from both sides. And that gives me negative 16 equals negative b squared. So b squared equals 16. Now if you wanted to actually find b, b in this case would equal 4. I'm not going to take that extra step because we're going to square it anyway underneath our fractions. So a is my part of my major axis, and my major axis was vertical, which means I'm going to put a squared underneath the y because y represents vertical movement. So I have 25 underneath my y, and then my b squared is going to go underneath the x. And then there is your equation for that ellipse. For letter C, the endpoints of the major axis are at negative 7, 2 and 5, 2. The endpoints of the minor axis are at negative 1, 0 and negative 4, 0. I always want to start by finding my center. So my center is going to be the midpoint between these 2 points. So the midpoint from negative 7, 2 to 5, 2 is going to be at negative 1, 2. So I can go ahead and write the top part of my equation. So I have x minus negative 1, quantity squared, plus y minus 2, quantity squared, equals 1. Now A represents the distance between your center and one of the endpoints of your major axis. So from negative 1, 2 to negative 7, 2, that is 6 units. So that means A is going to be 6. Negative 1, 2 is also 6 units away from 5, 2, so you can pick either of these endpoints. B is the distance between your center and one of the endpoints of your minor. So if my center is at negative 1, 2, I have an endpoint of my minor at negative 1, 0, B is going to be 2. Same thing over here, negative 1, 2 is 2 units away from negative 1, 4. Now we need to figure out if your major axis is vertical or horizontal. So if you look at your endpoints of your major axis, it's your x-coordinates that are different. Okay, so your x-coordinates changed. So that means for this one you have a horizontal major, which means our bigger number is going to be underneath the x. So a squared is going to be underneath the x, b squared is going to be underneath the y. And then that is your equation for the ellipse. For letter D, we're given that the major axis is 8 units long and parallel to the x-axis. So a major axis that's parallel to the x-axis is going to be horizontal because your x-axis is horizontal. So we know that this is going to be a horizontal major. Okay, the entire length across is 8 units. So that means A is going to be 4 because your entire length across is 2 times A. We know the minor axis is 2 units long, so that means B is going to equal 1, because we want to cut that in half. We also know that our center is at -2, -5, so I can write the top part of my equation. So I have x minus -2, quantity squared, plus y minus -5, quantity squared, equals 1. We know we have a horizontal major axis, so that means a squared is going to go underneath the x. And then b squared, which is 1, is just going to go underneath the y. You don't necessarily have to put the 1 there if you don't want to, but there is your equation for letter D. For E, we have the endpoints of our major axis are -8, 4, and 4, 4. So looking at that, we can figure out where our center is. Our center is going to go from -8, 4. So -8 plus 4 is -4 divided by 2 is -2. And then my y coordinate is still just going to stay 4. We can also figure out what A is, because A is the distance from your center and one of the endpoints of your major. So from -2, 4 to -8, 4 is 6 units. And -2, 4 to 4, 4 is also 6 units, so A is going to be 6. Now since we're given our foci, we can figure out what C is. So C is the distance from your center to one of your foci. So from -2, 4 to -3, 4, that is 1 unit. And then -2, 4 to -1, 4 is also 1 unit. So I know the foci, I have C, I can use this formula, C squared equals A squared minus B squared, to be able to solve for B, which is what we need to look for to write the equation. So my C is 1, so 1 squared is 1, equals A squared is 36, minus B squared. Subtract 36 from both sides. Divide both sides by -1, and you get B squared equals 35. You can square root it if you want to, but we're just going to square it anyway because you always have A squared and B squared underneath your fractions. So I'm just going to leave it. I'm just going to stop right here. I have my center, so I can write the top part. So that's x minus -2, quantity squared, plus y minus 4, quantity squared, equals 1. We still need to figure out if our A is going to go underneath our x or our y. So if you look at the endpoints of your major axis, it's your x coordinates that are changing. So that means A squared is going to go underneath my x. And then B squared is underneath my y. And this is your equation. All right. Last but not least, we are changing our equations in expanded form into standard form. So to do that, what we're going to have to do is complete the square. So I'm going to go ahead and move my 11 to the other side and rearrange so my x's are together and my y's are together. This is a typo. It should be minus 16y equals 11. For my x's, I'm going to go ahead and insert my blanks. Now for the y's, since we do have the number in front of our y, we need to factor that out first. So that's going to be y squared minus 4y, because you also need to factor out the 4 from this term as well. Plus a blank equals 11 plus a blank, because we need our equation to stay balanced. In my first blank, I can go ahead and put a 9, taking half of -6 and squaring it. For my second blank, taking half of -4 and squaring it, and that gives me a positive 4. Please be careful. Do not put a positive 4 over here. You're taking 4 times 4, which is 16. I can go ahead and factor these quadratics. So that leaves me with x minus 3, quantity squared, plus 4 times y minus 2, quantity squared, equals 36. Now our standard form equations for ellipses always equal 1, so we need to divide both sides by 36. Just make sure you divide everything by 36. So this leaves me with x minus 3 quantity squared over 36 plus y minus 2 quantity squared over 9, because I'm reducing 4 over 36, equals 1. And then there's our equation in standard form. For letter B, I'm going to go ahead and rearrange. So I have 4x squared plus 8x plus 6y squared minus 36y equals negative 34, because I'm moving this 34 to the other side. I'm going to go ahead and factor the 4 out of my x's. So that gives me plus 2x plus a blank plus 6. I'm going to go ahead and factor out my 6 from my y, so it's y squared minus 6y plus a blank equals negative 34 plus a blank plus a blank. For my first blank, I'm taking half of 2 and squaring it, which is 1. Please be careful, do not put a 1 over here. You're taking 1 times 4, which is 4. For this one, I'm going to take half of negative 6 and square it, so that gives me 9. So I have 9 times 6, which is 54. And then from here, I can go ahead and factor my quadratics. So I have 4 times x plus 1 quantity squared plus 6 times y minus 3 quantity squared equals negative 34 plus 4 is negative 30 plus 54 is 24. And now our equation needs to equal 1, so I'm going to go ahead and divide both sides by 24. And then reduce. So I have x plus 1 quantity squared over 4 over 24 reduces to 1/6 plus y minus 3 quantity squared. 6 over 24 reduces to 1/4 equals 1. And this is our equation in standard form. And standard form is helpful, especially if we were to graph our ellipses. All right, hope that helps. See you in class.